Welcome back to Aurora Tech Channel. Today, I will review the SOVOL SV08. This machine is based on the Voron 2.4, with SOVOL calling it their extension of Voron, and it's priced at $549. So let's take a look at the features. It's a Core XY machine with a print volume of 350 by 350 by 345 millimeters. It uses linear rails on the X, Y, and Z axis. The Z axis is supported by 4 linear rails with independent stepper motors and drivers, so it can level itself while the print bed stays unmoving at the base. The frame is a custom aluminum frame instead of being made of 20 by 20 or 20 by 40 extrusions. The extruder is a planetary gear extruder. The maximum nozzle temperature is 300 degrees Celsius. Their website didn't specify the type of the nozzle, but it looks like they're resistant plated nozzles, so I will also try some high temperature and abrasive filaments in this video. The hot end and nozzle are similar to those on the BambuLab X1. The machine doesn't come with an auxiliary cooling fan and mainly uses the turbo blower inside the print head, along with an extra blower at the back of the print head. Additionally, there's an inductive sensor for auto bed leveling, a tool height gauge at the end of the print bed for auto Z offset, similar to the Cobra 2 Pro, and a wiping pad for nozzle cleaning, similar to the BambuLab A1. The claimed top print speed is 700 millimeters per second, and the maximum acceleration is 40,000 millimeters per second cubed. The maximum flow rate of the hot end is 30 millimeters cubed per second. The heated bed is an AC heated bed, which can reach up to 100 degrees Celsius. The print surface is a single-sided textured PEI sheet. It runs standard clipper firmware on an MKS Pi motherboard with a quad-core 1.5 GHz processor, 8 GB of eMMC, and 1 GB of RAM, and a pretty standard clipper motherboard configuration. It uses silent stepper drivers and supports sensorless homing. The screen is a classic LCD screen by default, but you have the option to purchase another 5-inch touchscreen to run a clipper screen or use any clipper pad or Linux computer or tablet to run a clipper screen as a touchscreen UI. There's an accelerometer inside the print head for you to recalibrate input shaping, even though input shaping and pressure advance were both pre-calibrated in the factory. For other features, it has a 720p camera, filament sensor, LED light, and it supports USB, Wi-Fi, and Ethernet printing. For the price of $549, it looks like a better option than spending over $1,000 for a Voron kit from AliExpress. I would like to thank SOVOL for sending us this machine and for sponsoring today's video, and with that, let's get started. The box of the machine is quite large, and it weighs around 46 pounds. The parts are separated by a few layers of cut foam, and they all arrived in good shape. We have the base with the fixed print bed, the Core XY frame, the top frame of the machine, the print head connected to the base, a filament holder, a small LCD screen, and 4 Z axes with 4 independent stepper motors. The accessories and tools are packed in another box, which came with some better quality hex drivers. We will put the machine together, starting by attaching the 4 Z axes to the base. Then we'll put the top frame on, securing the whole frame. Next, we'll attach the Core XY frame to the Z axis. After that, we'll mount the print head, tighten some screws, and put back the magnetic print head cover. We'll connect some cables, and the printer will be ready. Since there's no touchscreen or setup wizard, I will use the LCD screen to perform some calibrations. Inside the leveling menu, there are 3 options. Let's start with the first one, Calibrate Z Offset. It will home itself and then probe the 4 corners of the bed to adjust the height of the 4 stepper motors to level the gantry. Then, it moves to the back of the print head to clean the nozzle and use the tool height gauge to set the Z offset. After that, it will level the corners again and start a small area bed leveling. The print head then moves to the front left corner and waits for the nozzle to heat up to 250 degrees Celsius. It then starts printing a simple pattern as a test print. As you can see, the Z offset is a bit too low, but I guess it should still work for most prints. I will go back to the leveling menu, as the quad gantry leveling has already been done with the calibrating Z offset. However, the bed leveling is only for the printing area. I will just do a round of auto bed leveling to let it probe the entire bed. It looks like it's going to do a 9x9 mesh to probe 81 points. After it finishes, it will reboot and save the mesh. The final thing we need to do is calibrate input shaping. This feature was inside the advanced menu, but the name is pretty confusing as it's called auto calibrate. It actually means input shaping. It will calibrate both X and Y. After around 10 minutes, it will be done, and we can now set up the Wi-Fi. According to the instructions, you need to edit a text file inside the USB drive and enter your SSID and password, insert it back, and power on the machine. However, after a few attempts, it still shows 127.0.0.1, which means it didn't connect to my Wi-Fi network. I experienced something similar with other Clipper systems like the Big Tree Tech CB1 board. I will try using an Ethernet cable and let the machine connect to my network. Then, I will see if I can use the Linux Network Manager to configure the Wi-Fi. After the Ethernet is connected, it shows an IP address. I will try to connect using SSH. The default username and password of the MKS motherboard are MKS and MakerBase, but it seems they changed it. I could log in with the username SOVOL and password SOVOL. I will use the Network Manager to set it up manually. I will enter the SSID, select the security type, enter the password, and give this connection a name. Then I will go back one step and activate it. Going back to the terminal, I will check the IP address. It seems to be working as we have the Ethernet IP, which I'm currently using to connect SSH, and we also have another IP obtained by the Wi-Fi adapter. I will unplug the Ethernet cable and let it refresh the IP address. Okay, it has been changed from .1.7 to .1.117. Let's start our first print, the 3D Benchy sample G-code. I will let it print a few more layers, reach the top speed, and then do a sound test. The sound meter is about 6 inches away from the machine, and the sound level stays around the low to mid 60s. As an open frame printer, it's not bad. The print finishes in 19 minutes, including the heating time, gantry leveling, and small area bed leveling. All those calibrations took around 7 minutes, so the actual printing time is around 12 minutes, which is pretty fast. The surface quality is not bad, with just a tiny bit of stringing. We can see some ringing here and the cooling is alright, but these layers are not printing too well at this high speed. But overall, it's a decent benchy considering this 12-minute printing time. Let's continue with our benchmark test prints, starting with the number slider to test the clearance. The clearance of the first layer is good, as we can clearly see gaps between the tiles. In fact, I would say the gaps are a little wider than normal, which means the Z height is a bit too high. As the printer only came with the small LCD screen and there's an optional color touch screen, my review unit didn't come with that. So I will use my Big Tree Tech Pad 7 to control this printer. I've used this pad to control other printers as well. Since this machine is just using standard Clipper, we can actually use any Clipper pad or any computer with a Linux OS to run the Clipper screen UI and add the IP address of the printer to control it. The print finishes in 1 hour and 58 minutes, which is way faster than the average of a 2.5 hour to 3 hour printing time. The top is alright with just minimal stringing. The clearance should be good, as you can see the tiles from the bottom are not connected to each other, but I would say the Z height is a bit too high. That's fine for this print as we would prefer more clearance on the first layer. Let's check the clearance, and all tiles can move freely. Then, I will print the Honeycomb box. The purpose of this print is to test the retraction of the extruder. The bottom is printed alright. The whole first layer can stick to the bed nicely, unlike the number slider which was a bit too high. So it seems the Z height of this print is just right. The print finishes in 2 hours and 12 minutes, which is a little faster than the average 2.5 hours. There is some stringing, but all patterns could be printed without any broken honeycombs, and the bottom was also printed without broken patterns, but again with some stringing. Let's compare it to other printers with better results. The print from this SV08 is not the best among the best, but it's still in line with other latest generation clipper printers. Up next, I will print a simple model with cylinders and squares to test the tolerance and see if the parts can fit together. Surprisingly, this print is way faster than any other printers I've tested. The average time is around 2 hours and 45 minutes to 3.5 hours, but this SV08 took just less than 1.5 hours to finish. I can see some warping at the corners as the Z height seems to be a little too high again. When you look at the bottom, the first layer wasn't squeezed down low enough on the textured PI sheet. However, the clearance of the square can clear from 0.225mm all the way to the tightest 0.05mm, which is perfect. The cylinder can also achieve a perfect tolerance from 0.225 all the way to 0.05mm. So, despite a bit of warping due to the inconsistent Z height, this print is the fastest with the perfect tolerance score that I've ever printed. Then I will print the Robo Alpaka from Prusa. This is a decorative print. The purpose is to test the surface quality and speed. On my first attempt, the Z height is once again a bit too high, which made this model have a small contact surface on the bed and therefore fail. I restarted the print with glue applied, and I manually set the Z offset to negative 0.05mm. It seems the bottom is sticking well this time. The body of the model has a lot of room for the print head to accelerate, so the print speed looks really fast when it's printing the infill of the body. The print finishes in 3 hours and 6 minutes, including heating and calibration, making it way faster than any printers I've ever tested. The print quality doesn't look too bad. Let's take a look from all 4 angles. The surface is not perfect, and we can see some ringing. There's also some stringing at the top, but considering the speed, the print is definitely still acceptable. Let's compare the result with other printers, starting with some Core XY machines. Compared to the QiDi Q1 Pro I tested last week, the speed of the SV08 is a clear winner, but the surface quality of the Q1 Pro is better. Compared to the BambuLab P1P, the speed of the SV08 is also much faster, but the surface quality of the P1P is better. Compared to the Creality K1C, the SV08 wins for the speed, but once again, the surface quality of the K1C is better. When compared to bed slingers like the Ender 3 V3, the SV08 is a clear winner for both speed and surface quality. At the end of the day, it's still a Core XY, which can be expected to get a better surface quality compared to bed slingers. The final comparison would be to the Comgrow T300, which is also from SOVOL. The T300 is one of the fastest bed slingers, but the surface quality and speed are both still not as good as the SV08. Let's try some other materials, starting with TPU. I will print 2 TPU pads with Eryone TPU. The volumetric speed of TPU is set to 5 mm³ per second. When printing multiple TPU parts at the same time, it may result in more stringing, but as the stringing only shows up in the path where the print head travels between 2 parts, it's easy to clean up. The print finishes in 1 hour and 8 minutes, which is not too bad. As I just used a low infill and printed 3 tops, the top didn't cover the infill well enough. I guess adding another 1 or 2 tops would be better. The bottom is printed fine. They're functional, as I'm just going to use them by putting them under another machine to use as vibration absorption pads, so they should be fine. Then, I will print a larger trash can with PETG. Instead of vase mode, I will manually set it to print 4 bottoms and 3 walls to make it more usable, as vase mode will just print 1 wall. The first layer is almost perfect except for the center. I checked the magnetic bed after the print was done, and there's a blob at the center of the bed when it's heated up to 85 degrees Celsius, making the center of the bed a bit too high and closer to the nozzle. I set the volumetric speed to 15 mm³ per second, which is pretty high for PETG. As you can see, when printing at a 0.32mm layer height, the speed is 109 mm per second, and it topped the 15 mm³ per second flow rate. After the second layer is printed, you won't see the blob anymore. I guess there will be minimal or no impact on this print at all, so I will just let it finish. The print finishes in 8 hours and 51 minutes. There is some ringing consistently showing from the bottom to the top. It may not look that perfect, but it's better than using a bed slinger to make a tall print like this. The bottom looks alright, and it seems the imperfect first layer at the center doesn't look obvious on this print. Next, I will print ABS on this open frame printer. From SOVOL's website, it has an optional enclosure, but my review unit doesn't come with it, so I would just try to print ABS without an enclosure. I applied more glue on the bed, so it won't be a problem for the ABS to stick well on the print surface. The print finishes in 2 hours and 46 minutes. This is another record for this ABS crate in terms of speed. This model normally takes 3.5 hours on other clipper machines. It has some stringing, but the print warped a little at the corners, but that's normal when printing this tough ABS print on an open frame printer. The cooling was off, so the overhanging may not look as good as printing PLA. In terms of print quality, it's an average print for ABS on an open frame printer. If you're gonna print ABS, adding the optional enclosure would be necessary to get better print quality. As the maximum nozzle temperature is 300 degrees Celsius, I will also try to print with polycarbonate. After changing the filament, I forgot to remove the purged filament. It stuck on the print head, but it seems it didn't get into the print. After a few layers, it was detached from the print head. It continues to print normally. When printing polycarbonate, I didn't slow it down and it was printing at the same speed as ABS. Even though this model is small and it doesn't have much room for the print head to accelerate, the top speed can still reach around 180 to 200 millibits per second. The print finishes in 38 minutes. Despite a bit of stringing, it's a pretty solid functional part. This printer came with 2 nozzles. Their website didn't specify what type of nozzle it is, but it looks like a kind of wear-resistant plated nozzle. So I would try to print some high-temperature nylon carbon fiber. This filament from Phaetus requires a printing temperature of 300 to 320 degrees Celsius, so I would just try to print at 300 degrees Celsius. I will print a lens cap for our new vintage camera, the Argus Model A, which was manufactured in 1936. This small print just took 39 minutes to finish. As we spent quite a lot of time cleaning this camera to make it work like new, we also laser cut a small piece of leather to make a logo on the cap. We are really happy with this 88-year-old camera, which can take some pretty cool pictures. Even though the exposure of the pictures isn't perfect, we're still having a lot of fun with it. Finally, I will recalibrate the Z offset and do the first layer test. I will print a PLA sheet and see if it can achieve a good result. Besides the top right corner, the first layer is pretty much perfect. I can peel it off from the print surface without separating the lines. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. Since this machine is based on the Voron 2.4, it uses the same movable gantry supported by 4 stepper motors with 4 independent stepper drivers. This could be the best solution for maintaining the level of the gantry. 2. It also integrated other features from other machines. As far as I can see, the hot end and nozzle are similar to the ones on the BambuLab X1. The nozzle wiping pad is similar to the A1, and the tool height gauge is similar to the Anycubic Cobra 2 Pro. So, as SOVOL said, this is an extension of Voron. 3. The print speed of this machine is obviously faster than most Clipper 3D printers on the market. It has set a few new speed records in our benchmark test prints, and the results are still acceptable. The Core XY linear rail motion system allows the print head to move quickly, while the extruder pushing force on the hot end can melt filament rapidly. Additionally, an extra turbo fan is added at the back to improve part cooling. All these factors are major contributors to successful high-speed printing, and this machine checks all the boxes. 4. The linear advance is well tweaked, and the tolerance test is not only the fastest I've ever printed, but it also achieves a perfect score for both the square and cylinder, which is truly unexpected. 5. It comes with a simple LCD screen, and you can use any Clipper pad or Linux computer to install the Clipper screen to control the printer. Alternatively, you can purchase their color touch screen. Honestly, I would prefer using the standard Clipper screen rather than other self-developed screen UIs. Keeping the Clipper firmware and screen UI as original as possible will be best for budget printer manufacturers. Now for the cons. 1. The Z offset is inconsistent. I noticed this issue starting in the first few test prints. The Z calibration test print looks fine, but the following prints are super inconsistent. Some are just right, while others are too high. I suspect that this inconsistency might be caused by the Z homing speed being set too fast. Instead of 15 and 10, I found that slower speeds work better. Generally, I would set it to 5 or sometimes as low as 3, depending on the performance of the bed leveling sensor. 2. The nozzle cleaning and auto Z height gauge are only used during Z offset calibration. Since the hardware is already available, SOVOL could optimize their use by setting the Z offset to use the gauge before every print starts. This could potentially improve the consistency of the first layer. By recalibrating the auto Z offset according to the actual printing temperature, this issue could be avoided. 3. The magnetic bed of my machine didn't stick well to the heated bed. When I print PETG, the center of the bed had a blob. When I printed the PLA sheet to test the first layer, the print was almost perfect except for the top left corner. Upon checking the magnetic bed again, I noticed that the corner was not fixed too well and lifted up. Generally, heating up the bed to the highest temperature, lifting the magnetic bed up a little, and reattaching it can fix the issue. However, using some strong magnets like those on the Prusa and BambuLab machines could avoid this problem altogether. With those magnets, the print bed can heat up to 110 or even 120 degrees without worrying that the magnetic bed will deform. 4. The Wi-Fi setup procedure is not smooth. I tried following the instructions to edit the text file on the USB, reinsert it, and turn the machine on several times, but it just can't connect to my Wi-Fi network. However, when I use an Ethernet cable to log into the Linux system and set up the Wi-Fi adapter manually, it works perfectly fine. So it's not a hardware issue, nor is it a Wi-Fi router compatibility issue or a Wi-Fi signal issue. It seems to be a firmware or Linux shell script issue, as the script used to copy the Wi-Fi info from the text file to overwrite the existing network settings is not working as intended. 5. The print speed is faster than most Clipper machines, if not the fastest, and the accuracy remains pretty good even at high speeds. However, there is a trade-off with surface quality. For example, compared to other Core XY machines, when printing the Robo Alpaka, the SV08 can print 30% faster. However, the surface quality falls between that of a bed slinger and a Core XY. The first print finished in just around 3 hours. I slowed it down by 20% for a 3.5-hour print, and the surface quality noticeably improved. In conclusion, the machine performs quite well and has pleasantly surprised me in terms of speed and accuracy. In terms of performance, it's the best SOVOL machine I've ever tested. While it did have a minor issue with the magnetic bed and software issues such as the homing speed and Wi-Fi setup, these are not deal breakers. They may be a little frustrating for beginners, but for those with some experience with 3D printing, they aren't that big of a deal. For complete beginners seeking a hassle-free experience, the SV08 may not be the best option. However, for intermediate and advanced users planning to invest $1,000 or more in building a Voron, you will be happy with this SV08 as a more accessible and convenient alternative. Even if you get the most basic Voron kit with the basic V6 hot end, where you still need another 3D printer to print all the parts, after adding shipping, you're likely to spend around $1,000, even if you find the cheapest seller from AliExpress. Compared to the complexities of building a Voron from scratch and other unknown variables from the inconsistent quality of Voron kits from different sellers, dealing with the SV08 is a much more manageable option. Moreover, the SV08 is only half the price and still performs pretty well, making it a more cost-effective choice overall. This printer has a lot of potential as it is fully open source, so you can tweak the firmware as much as you like, and I won't be surprised if I see some community firmware in the future. If you're interested in this SV08, I've included its link as well as a link to my website, auroratechchannel.com, where you can find my recommendation list and a price tracker that monitors 150 popular machines updated hourly. All relevant links are in the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.